So this is that same formula we're using today as we used the other Friday with the speed of the wave, the wavelength of the wave, and the frequency of the wave. F equals lambda times, sorry, that's a V. V equals lambda times F, where V is the speed of the wave, lambda is the wavelength of the wave, and F is the frequency of the wave. Now y'all don't start yet, hold on. I don't want y'all to get done and have nothing to do. So, these are kind of harder because it's got the big, scary scientific notation numbers, but it's really just fine as long as you remember how to use your calculator shortcut. My calculator has a little e that means times 10 to this, so I say 4.1 E14, and that means the same thing as 4.1 times 10 to the 14. So that makes it harder, but what makes it easier, so, you know, I'm not saying that the whole thing's harder because that's one part that makes it harder, but the other part that makes it easier, that may be offsetting, is this speed is always going to be the same on these problems. Now, the speed of light can slow down. If you put light through water or other dense things, light will slow down, but if it's through just a vacuum or, you know, it gets close to this in air also, it'll be going 3 times 10 to the 8 meters per second. So in this, the speed of light will always be 3 times 10 to the 8 meters per second. And you'll just be looking for this one or looking for this one, which makes the math really easy. No matter which of those you're looking for, it'll be pretty much the same every time. So I'll show you here. First I'm going to find the color of this light, which is, there's a little bit of a trick to it because this gives you frequency and wavelength and terahertz and nanometers. That's what they use to match up with the colors. Just to make it easier to say, so every time you say the wavelength, you're not saying like this times 10 to this, whatever. So this gave us, since we're doing math with it, it gave us hertz, and it gave us meters instead of terahertz and nanometers. So the way to figure this out, in your instructions I gave you these little equivalencies here. So it tells you to get this hertz and terahertz, bless you, 1 terahertz is 1 times 10 to the 12 hertz. That doesn't really help us because ours is 10 to the 14. But it tells us 100 terahertz is 1 times 10 to the 14 hertz. So if 1 times 10 to the 14 hertz is 100 terahertz, this 4 times 10 to the 14 hertz would be 400 terahertz. Does that make sense? And 4.1 times 10 to the 14 hertz would be 410 terahertz. And that's how we can match this up. So 4.1 times 10 to the 14 is 410 terahertz. And let's see, that's not 410. There, this one. This has 410 in it, 400 to 484. So then this one would be red. And here, okay. My marker's purple. I'll write red with a black marker. Is that better than writing red with a purple marker? That really bothered me last time. Fine. So there. Red. And let's try this one. 6.9 times 10 to the 7 meters. 10 to the negative 7 meters. That's a wavelength. We need to get it to nanometers over here. So it's got a little thing over here too. So 1 nanometer is 1 times 10 to the negative 9 meters. Well, we've got 10 to the negative 7. But 100 nanometers is 1 times 10 to the negative 7 meters. So, okay. So 1 times 10 to the negative 7 meters is 100 nanometers. We have 6.9 times 10 to the negative 7 meters. So let's just start with a 6. So 6 times 10 to the negative 7 meters would be 600 nanometers. 6.9 times 10 to the negative 7 meters would be 690 nanometers. So if I go look for 690, 590, 620. There, it's in there again. It's red again. What is this? Is everything red? Not everything is red. The first two are red, but others have different colors. Yes, but I'm not writing that one down. And I'm not giving you any more answers except for this one answer and this one other answer. So here, I'll use my purple marker now that I'm not writing colors down. So it's asking what's the wavelength. So I'll say my little wavelength. Remember, this is our lowercase lambda Greek letter for wavelength. What's the wavelength of an electromagnetic wave? It's an electromagnetic wave. That means it's light. That's the same. Just another way of saying light. So we know our speed is going to be that 3 times 10 to the 8. So I'll write that down. 3 times 10 to the 8 meters per second. And oh, it gives us a frequency. Frequency equals 4.1 times 10 to the 14 hertz. Okay, it told me. The frequency is this, and the speed, because it's an electromagnetic wave, and light, aka electromagnetic waves, is always goes that 3 times 10 to the 8, and all these questions occur in a vacuum.
So
Then,
V equals.
yeah, on all these questions, V is going to be that. V. So, like I said, the big numbers make it kind of more intimidating, but it's really kind of easier because V is always the same here. And it's always going to work out doing the same. So, if, let's see, I'm going to write my formula, and plug in for V, 3 times 10 to the 8 meters per second. Lambda is what I'm looking for, and the frequency, 4.1 times 10 to the 14 hertz. Boy, I hope they can see that. Can you see it? They can see that just fine, Mr. Franklin. Stop worrying. Okay. See, they can see all the way to over here. Dang. Hi. So here's where it's always the same, because it's always going to give you this one. V is always that. So you're never going to be looking for V. You know what it is. It's 3 times 10 to the 8. You're either going to look for lambda, or it'll give you lambda and you'll look for F over here. Either way, it'll be lambda times this, or F times whatever it gave you for lambda. So you'll want to get it to say equals the missing variable, and so since it's multiplying up here, you'll always divide, do the opposite, to find that other one. So since you're dividing both sides, you're going to always take the given number and say 3 times 10 to the 8 divided by that, and then it'll give you the number. And I did this one already. I got 7.32 times 10 to the something something something. 10 to the negative 7 meters. Okay, that's my answer. And you can check too, because we know this one's red. So I can go check. Okay, 7.32 times 10 to the negative 7. 1 times 10 to the negative 7 is 100. So 7 times 10 to the negative 7 is 700. So we're looking for 732. Let's make sure that's red. So red. Yeah, 732 is within that range. So we're good. We did it right. Isn't that neat? You can check your answers. I've also got the answers here. But, Now, I'll scroll back up in a minute. There's one other thing that it's going to ask you to do at the very end. If you have time, please do this. I think I made these questions not required. All right. So this involves a constant, so it's also easy. There's a couple of these that it'll ask you to it'll ask you for the wavelength and give you the energy, and so you'll have to go find the frequency with this formula, and then go find the wavelength with the formula we just used, or it'll give you the wavelength and say what's the energy of a such and such meter wave. You'll know it's wavelength because it's in meters, so you have to go plug it into the formula we just used, find frequency, and then come plug into here and find energy. Notice I'm not saying anything about H. H is a constant, so it'll always be the same. I'll do an example of one of these. So this one says, what's the energy of a such and such meter wave? So, okay, we're looking for energy. We've got the wavelength. 4.7 times 10 to the negative 7 meters. And well, that's all we know. I guess we know how fast it goes because it's an electromagnetic wave. What? 3 times 10 to the 8 meters per second there. Okay. Our formula is going to be E equals HF to find the energy. We know H, it's up there, it gives it to us, it's a constant. We're looking for E, we need to find F. We don't have F right now, that's why we have to use those meters to go get F. So you'll go and use that same formula we were just doing, that V equals lambda F, where V is 3 times 10 to the 8. I can say actually times 10 to the 8. Not everybody's calculator says that E, Mr. Franklin. 3 times 10 to the 8 meters per second equals, oh, we've got lambda, 4.7 times 10 to the negative 7 meters times F. And we'll go find F. It says F times that, so we'll divide both sides by that. And if I do that, I get 6.38 times 10 to the 14. That's Hertz. So that equals F. Is that right? What? No, I'm right here. Okay. Now I've got F, so now I can finally do that. So I'm doing E equals HF. H is the one it gives you on your paper is that 4.1357. I rounded it. I didn't use all those numbers. Times 10 to the negative 15. And I've got my F now. It's HF, so I did H, and here's F. 6.38 times 10 to the 14 Hertz. And if I do that, let's see, times 4.1357. I got 2.64. And this one uses electron volts for energy instead of joules. When we start talking about light, we're not dealing with big stuff anymore. We're dealing with little stuff. So it's more useful to use quantum units for this sort of thing. So electron volts for the photons and the electrons that we're dealing with end up being a little better. So I'm going to scroll that up. There we go. Now be careful, if you're using your shortcut on your calculator, like if you're saying 3E8 divided by 4.1E14, you can just put that in just like that, press enter, and it'll give it to you. If you're not using a shortcut, which you don't have to, I recommend it, but you don't have to, make sure you're putting the whole top and the whole bottom in parentheses. Otherwise, your calculator will say 3 times 10 to the 8 equals the number, okay. Divided by 4.1 equals the number, okay. Times 10 to the 14, but that's not what you want. You want parentheses 3 times 10 to the 8, close parentheses, divided by parentheses 4.1 times 10 to the 14, close parentheses, and then enter. Otherwise, it'll say this divided by 4.1 is a number, and then times, and it'll mess you up. But if you're worried about whether you're doing that right or not with your calculator, check the answers that I posted. This question's on there, so you can use that, but you can also check the ones that I posted. Remember, those are just so y'all can get on the right track and check your answers, not to copy. That's how you fail a test, is copying those because you don't know how to do it. Anyway, y'all got questions about this wavelength frequency and energy? All right. Please go to that wavelength frequency and energy assignment.